So in this problem, we started by giving you a line and giving you an equation for a line, y equals negative 5 fourths x minus 6, and then asking you to produce for us an equation of a line that is either, depending on which one you worked on, parallel to that given line or perpendicular to that given line, and which passes through a selected point, negative 4, 3. So, first of all, first row, you were given the task of finding an equation for a line parallel to this one, and what did you say? What was an equation for that line? Somebody want to speak for your first row?
I got y equals negative 5 over 4x minus 2.
Y equals negative 5 over 4x minus 2. All right, and second row, you had the task of doing the same thing but with perpendicular instead of parallel. And what did you find?
We got y equals 4, 5x minus 2 over 1. 1 minus 6, but I just put it.
I'll simplify that to have a minus 2. Okay, so interesting. First of all, what does everybody notice about the differences between these two lines? What's different about the answer to part A and the answer to part B? Slopes are opposite in what way? Yeah, so on the one hand, the slopes are reciprocal. Right? We flip the fraction upside down. And on the other hand, what else? One of them is negative and the other one's positive. Right? So that is the relationship between two slopes of lines that are perpendicular to one another, right? Perpendicular means take the opposite and the reciprocal as far as slopes go. What's the same about these two lines?
Same line, you
Yeah, look at that. Negative 2 would appear to be the y-intercept of both lines. That may be a coincidence. Let's try and sketch out these lines just to make sure that we have kind of a reality check on what we just did. So on a coordinate system over here, let's sketch out the original line, y equals 5 fourths x minus 6, and we'll draw it here in gray. Y equals negative 5 fourths x minus 6. So if my job was to sketch this line, how would I do that? We didn't really have this conversation last Wednesday, so now is a good time. If you're just given an equation for a line like that, what are your steps in thinking about how to draw that line on a graph? Where do you start? Put in some.
Start with literally plug in for x.
Okay. So what are some things that we could plug in for x?
0.
I think 0 is always a good number to plug in for x. So if I plug in a 0 for x into this equation, what's going to come out for y? Negative 6, because after all, negative 6 is what for this line? It's the y-intercept. And plugging in 0 for x is exactly asking for the y-intercept of a line. So we start by just plotting the y-intercept on this graph at 0, negative 6. And then what? From there, what else do we do? So I know the line has to go through that point, but what else can we learn about it that will help us graph it? There's something we can do with this negative 5 fourths that can help us to sketch this line. So thinking back to what a slope actually means, and we're going to take the slope out of this line, negative 5 divided by 4. This equation, m equals y2 minus y1 over x2 minus x1, defines for us what a slope is. It defines for us what a slope means. y2 minus y1 is what we often call a rise. It's a vertical difference in 2 points on this graph. And x2 minus x1 describes what's often called the run, the horizontal distance between 2 points on this graph. So if my slope is negative 5 over 4, then one of the ways I can interpret that fraction, fractions are hard to interpret, they're tricky, they're subtle. But one of the things we can do is we can take the numerator and the denominator separately, each of those is a whole number, and we can use those separate numerators and denominators to give us an interpretation. For example, what would it mean to rise negative 5? What does that suggest that we can do? Rising by negative 5 means counting 5 units downward in the y direction. So from my point at negative 6, what I could do is I could count down 1, 2, 3, 4, 5, minus 5, down to a point down here on the y-axis, which would have a y-coordinate of negative 6 minus 5, or negative 11. But if I count downward by 5 on this graph, what else do I also have to do? If I rise by negative 5, I also have to run by positive 4, which means what? What does running by positive 4 indicate that we should do? Go to the right by 4 units. So from there, we'll go to the right by 4. And there we get a second point for our graph. I'm going to try and draw that a little bit more coherently here. So what we did is we went downwards by 5 units. I'll put that little arrow in there, so downward by 5. And then we went rightward by 4 units. Oops. Rightward by 4. And now I realize my arrow is kind of in the wrong place. There we go. Plus 4. And there we locate a new point. And as soon as I have 2 points, I can sketch my line. All it has to be is the line which goes through those 2 points. So that's a really powerful way to use the slope of a line to help to graph a line. Just take the numerator and denominator and use them separately. The numerator tells us how much we should be rising or falling. The denominator tells us how much we should be running, either to the right or to the left, depending on whether it's positive or negative. So the slope gives us that directionality by thinking of the numerator and the denominator separately. So there's our original line given to us in this problem. Y equals negative 5/4 x minus 6. So, just as a reality check, let's plot these 2 lines that you gave me for your answers and make sure that those lines are doing what we expected them to do. Starting with the line in part A, y equals negative 5/4 x minus 2. If I were to plot that line, and I'm going to do that in orange here, where would I begin the process of plotting that line? Just like the first example, start with the y-intercept. Because this line came to us in slope-intercept format, we can read directly off of that equation. What's b? Negative 2. So if b is negative 2, I can start at negative 2 on the y-axis as my first point. It's good information to have because it gives us a place to plant our feet. And then what do I do with this negative 5/4? Down 5 and over 4, exactly the same as what we did last time. If I go down 5, I go from negative 2 on the y-axis down to negative 7 on the y-axis. And if I then go to the right by 4, I go from 0 on the x-axis over to 4 on the x-axis. And I'll locate my graph. My graph axes are really poor on here. I'll locate a new point, and then I'll just sketch the line that passes through those 2 points. And I'll have the line that I'm looking for. So because my 2 slopes were the same, the 2 lines that I plot are guaranteed to be parallel. So we have the parallel part. Let's just double check that this point also passes through the point negative 4, 3. So for that, if I had a more accurate graph, we could just look over where x is equal to negative 4 and try and locate this point and see if it's actually on the graph, negative 4, 3. Since my graph is really shoddy, let's do it with algebra also. If I plug a negative 4 into this equation for x, what am I going to get for y? So let's plug it in. Negative 4 for x. I've got negative 5/4 in front of it, minus 2. Negative 5/4 times negative 4, well, the negatives times the negative is going to give me positive, and then the 4 in the denominator multiplied by the 4 in the numerator is going to give me, well, those are going to cancel. So it's going to give me positive 5 is all that's left, minus 2. And oh, look at that. When x is negative 4, y is 3. So we don't have to believe our eyes because my graph is terrible. We can believe the algebra, which confirms for us that this line does in fact pass through the point negative 4, 3. And it has the same slope as the original, therefore it's parallel to the original. So we did it. You did it. First row. You got this equation for part A. It satisfies both of the conditions we needed to satisfy. So how about that second equation? The one which is perpendicular to the original line and which passes through the point negative 4, 3. Let me sketch that in. I got to find a new color for myself here. So y equals positive 4/5 x minus 2. If I graph that, I'm again going to start at the y-intercept, which again is negative 2. And then from there, now my slope is positive 4/5. So how do I understand how to use that slope? What's a slope of 4/5 going to mean that we should do in order to find the next point on this line? What's this 4 on top going to tell me?
Can we actually change our y?
You want to change your y-intercept. Okay, change it to what?
31 over 5, so plus 31 over 5.
All right, so you're amending your answer, perhaps because you saw the writing on the wall, quite literally, over here. Yeah, if I were to sketch a line with a slope of 4/5 from this point, it's not going to pass through the point negative 4, 3, the way that we want it to. So yeah, I think the y-intercept we want is not negative 2. You're saying it's 31 over 5, which would be slightly more than 6. It would be 6.2, so it's up here somewhere. 31 over 5. Okay, so that's our new y-intercept, and we'll forget that that old y-intercept ever existed. Except that in the video, we'll know better. Okay, so from there, now we need to use the slope 4/5. So if 4 is my rise and 5 is my run, what does that mean I want to do? If 4 is my rise, what I want to do is go up 4. And if 5 is my run, I want to go to the right by 5. Up 4, right 5. Which means I'm going to eat into my space over here. Let's try and clear that out. So I'm going to go up 4 from this point, and then over to the right by 5, plus 4, plus 5, and there's going to be my new point. And then I'll, from there, sketch my line. Oh, I need to do a better job of making my axes look good. Up 4, up 4, right 5, plus 4, plus 5. Here's my new point. I'll sketch the line through those points. I did a really poor job. In fact, I did an especially poor job because this doesn't even look like it's perpendicular. And it also needs to pass through negative 4, 3. Well, okay. We'll draw a more accurate picture in a moment. First, let's just double check that this line actually does go through the point which we advertised it would go through. If I plug in a negative 4 in here for x, let's verify what we get for y. 4/5 times negative 4 plus 31 over 5. Multiplying a fraction by a whole number, we'll put a denominator of 1 underneath it and then multiply across. That'll give me negative 16 over 5 plus 31 over 5, which already has a common denominator, so that if we add it across, 31 minus 16 is 15, and 15 over 5 is 3. So as advertised, when the value of x is negative 4, the value of y that we get is 3. So it passes through the point we need it to pass through. Its slope is the opposite reciprocal of the original, and so it must therefore be perpendicular. Let's get an accurate graph of this just to wrap up, and for the sake of fidelity, because that way when you look back at this video later on, the diagram will actually make sense. So I was really lax with my original diagram here. All right, so here's a set of graph axes. The original line, y equals negative 5/4 x minus 6. As we said before, we start graphing that line at the y-intercept, 1, 2, 3, 4, 5, 6, negative 6. And then from there, we find another point by going down 5 and to the right 4. So 1, 2, 3, 4, 5. that takes me down 5. And then 1, 2, 3, 4, that takes me to the right 4. Here's my new point. And then I'll just draw a line through those 2 points, and there's our original line that was given to us in this problem. Again, I'm trying to make this as accurate as possible so that our graph is super meaningful at the end of the day. There we go. So there's our original line, y equals negative 5 fourths x minus 6. The line which you said was parallel to it and which passed through the point negative 4, 3 was y equals negative 5 fourths x minus 2. To graph that line, we started at the y-intercept negative 2 this time, and we followed the same down 5, right 4 mentality that we did for the first line that we sketched. So I'm just going to draw that same little set of arrows here, down 5 into the right by 4. That locates our second point, and then when we plot that second point, we end up with this new line, parallel to the original. So that was definitely something that we needed. But the other thing that we needed this line to do is we needed it to pass through the point 4, negative 3. And if I look on this graph for the point 4, negative 3, I'm going to find it, negative 4, 3. 4, 1, 2, 3. So when I go to locate the point negative 4, 3, sure enough, there it is. There's the point negative 4, 3 that we needed it to pass through. So that equation worked the way that we wanted it to work. Negative 4, 3. And then last and certainly not least, we had the perpendicular version. And perpendicular, as always, is an opposite reciprocal slope. And then when you found the y-intercept of this one, you got kind of a nastier number, 31 over 5. So to graph that equation, you went up to 31 over 5. 1, 2, 3, 4, 5, 6.2. So that y-intercept was right here, 31 over 5. And to plot that line, we had to go not down 5, right 4, but up 4, right 5. So that's going to look like this, up 4 and right 5. 1, 2, 3, 4, 5. And then when we plot that line, there we go. When we plot that line, we see that 2 things are true. First of all, it also passes through this magic point, negative 4, 3, that we needed it to pass through. But then also, that line, crucially, is perpendicular. It makes a right angle with, well, most important is it makes a right angle with the original line, which is what we were looking for. But because the red line is parallel to the original, it also makes a right angle with that line as well.